Hello, this is Mr. Huff. I want to go through a problem. This is an example. So we have an aircraft that is going to take off. It's loaded at 88% of its maximum takeoff mass, which is 101,875 kilograms. What's the minimum acceptable coefficient of lift in the following conditions? If the air density is 0.999, the wing surface is 141.6 square meters, and the nominal takeoff velocity is 72 meters per second. So we have some things to do before we can even get started. So let's see. First thing we want to do is, so we're just going to follow guess. We're going to move straight through this. And so my first given, I'm going to look at things like the velocity is 72.0 meters per second. I'm just going to write the rest of these down. Area 141.6 meters squared. Rho, air density, is equal to 0.999 kilograms per cubic meter. Let's go up here and look at this. Also have a mass. So mass equals 101 point, no, comma, 01875 kilograms. Over here, it's loaded 88.8%. It's an unusual number there. Okay. We also need to know that gravity is 9.81 meters per second squared, because we have to get this to turn into a force. Unknowns. CD. Coefficient of, CL. Coefficient of lift. No unit. We also need to know the lift, which is equal to the weight, which is equal to mass times gravity. And we know that that is going to be multiplied times 0.888, which is from here. Okay. Let's talk about this right here. Okay, so we know that the lift has to be at least equal to the weight, so that's going to be our minimum takeoff lift, and that's going to be equal to mass times gravity. And because it's loaded at 88.8% of its maximum weight, we know that we have to multiply that times 0.888. So that'll get us to our lift. With that in mind, we're going to go to equation next. Our equations that we need: weight equals mass times gravity, and the coefficient of lift equals 2L A rho V squared. Okay, now we're going to do some substitution. So we're going to go, I'm going to put a lot of this in at one time. So we're going to go that the coefficient of lift equals parenthesis 2 times the mass times 9.81 times 0.888 close parenthesis over area, which was 141 point something, 141.6 times rho 0.999 times velocity squared. Our velocity was 72, so we're going to go put 72. And we're only squaring the velocity, not the entire expression. Okay, with that, we can calculate our coefficient of lift, and you should get about So our coefficient of lift is going to be equal to 2.420. And again, there's no unit. So this is our final solution for that. So in review, one of the important things you need to pay attention to is that you need to take mass times gravity times 88% for this one, or whatever your percentage is to get to that lift. So anyway, there's that, and that's an unreasonably high coefficient of lift. So no, it's not. It's reasonable. But we're just going to run with that answer. That's what you should have gotten on that one.